Hello, welcome back for Chapter 4, Lesson 8, Introduction to Coordinate Proofs. So we have some warm-up problems here, 1, 2, and 3. And so here's my friend the pause dragon. Reminding you to pause your device, go ahead and work out those 3 warm-up problems. When you get done, press play and we'll go over them together. All right, see you in a bit. Okay, we're back. Let's see how you did on those warm-up problems. So the first one says find the midpoint between these 2 points. So remember that midpoint formula. Midpoint equals x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So it's the average of the x values and the average of the y values. We're going to go ahead and define our terms. This is my first point. And this is my second point. Then we just substitute those values in. So we're going to get 0 plus x2, which is 2y, all over 2. And then y1 would be 2x, and y2 plus 2z, all over 2. Then we're going to simplify. So here we have 2y divided by 2. And then here, what I'm going to do is I'm going to look here. I can't combine like terms, but what I do see is they both have a 2, so I can factor out that 2. And it will end up being 2 times x plus z. And then watch what happens here. 2 divided by 2, we're going to simplify this, right? That's 1, so we're left with y. And then right here, same thing, 2 divided by 2. 2 divided by 2 is 1. That becomes 1, and we're left with x plus z. So if you got that as your answer, great job. Okay? If you didn't get that and you stopped here or something, you need to go ahead and simplify further. All right, let's go here to number 2. It says one leg of a right triangle has length of 12, and the hypotenuse has a length of 13. What is the length of the other leg? All right, so it's a right triangle, so we can do the Pythagorean theorem, right? A squared plus b squared equals c squared. B is equal to 12. C is equal to 13. We substitute in. We get a squared plus 12 squared equals 13 squared. 12 squared, 12 times 12 is 144. 13 times 13 is 169. Pretty sure. Let me double check. 3 times 3 is 9. 3 times 1 is 3. Write the 0. 1 times 3 is 3. 1 times 1 is 1. 169. Yes, it is. Okay. And then we're just going to, what is the length of the other leg? What's the length of A? So we need to get A by itself. So we got to subtract 144 to both sides. We're left, that cancels. We're left with a squared is equal to 525, right? We got to get a by itself. So this is a squared. The inverse operation of a squared is a square root. So we're going to square root both sides. Square root cancels out squared. We're left with a equals square root of 25 is 5. It's going to be plus or minus 5. But when we're talking about distance, we're not going to have a negative 5. So that means a is equal to 5. That is the other leg. All right, so if you got that, you showed your work like this, great job. If not, go ahead and fix it. The last one, find the distance between 0a and 0b, where b is greater than a. All right, cool. So we're going to do distance formula, right? Distance equals x2 minus x1 squared plus y2 minus y1 squared. All right, I'm going to define these terms. So x1, y1, x2, y2. All right, we plug them in, and we end up with 0 minus 0, that's squared, plus y2 minus y1, which would be a. Okay, that looks great. And then we simplify. So 0 take away 0 is 0. 0 squared is 0, so we don't need to write it. We just have b. So that basically just goes away. B minus a squared. And then the square root and square root cancel each other out. We're left with b minus a. That is the distance between the two. Perfect. So if you got all those right, awesome job. So let's go ahead and look at what we're looking at. We're talking about coordinate proofs in this lesson. So a coordinate proof, what that is a style of proof, a coordinate proof, a style of proof that uses coordinate geometry and algebra together. The first step of a coordinate proof is to position the given figure in the plane. You can use any position, but some strategies can make the steps of the proof simpler. So we're going to look at what some of those strategies are. So you're going to have a figure, and you're going to position the figure in the coordinate plane, okay? So strategies for positioning the figures in the coordinate plane. Okay, so the first strategy is to use the origin. You know what the origin is, right? That's 0, 0. That's the origin. So the first strategy is to use the origin as the vertex, keeping the figure in quadrant 1. Okay? Another strategy is to center the figure on the origin. That's another strategy. And then a third strategy is to center a side of the figure at the origin. And the last strategy is to use one or both axes as sides of the figure. Okay? So let's go ahead and see what these strategies, what we're talking about. So here with example 1, what we have is example 1, we're going to be positioning a figure in the coordinate plane. So position a square, right? Squares, they all have the same side length, right? So position a square with a side length of 6 units in the coordinate plane. All right, perfect. So if I have a square, I think the first strategy I'm going to do is put a corner of it right on the origin. All right? And then it's a square of 6 units, so it's going to be 6 units this way. It's going to be 6 units up. And then it's going to be, you know, meet right here. So what I'm going to do, I'm going to draw my square. I'm going to label it A, B, C, D. And then I want to label those vertices. So this is 0, 0. This is 6, 0. This is 6, 6. And this is 0, 6. All right, you guys see that? And that's how I positioned that figure, a square of side length of 6 units in the coordinate plane. All right, let's look at this next example. It says, checking out example 1, position a right triangle with lengths of 2 and 4 units in the coordinate plane. Hint, use the origin as the vertex of the right angle. So in this one, we're going to use that vertex because the x and the y axis just naturally makes a right triangle. So, a right angle. So that's what I'm going to use. So one length is going to be 2 units. I'm going to have the origin as a vertex, right? Then we're going to have a length that's 2 units and a length that's 4 units. And then you just make your triangle. Okay. And then we want to label it. So this is X, and that's 0, 0. This is Y, and that's 2, 0. And this is Z, and that's 0, 4. All right? So we positioned it, we labeled it, we wrote the coordinates. All right? Yeah, that is it for this example. I'll see you in a little bit for example 2.